Hello everybody, today we're going to go over solving nonlinear inequalities from section 9.7. When we last solved our inequalities, we basically were solving them directly the same way that we would have solved linear equations with only one or two rules changed. In this case, when we talk about nonlinear inequalities, we're actually focusing on the quantities, the factors right here. And our whole goal right here, the biggest thing that you have to know when it comes to solving a nonlinear inequality, is that we want a nonlinear inequality set equal to zero. And the reason why is that when we're looking at our solution sets, we're actually looking at whether or not we come out with positive or negative numbers. And the best way to compare any number in terms of it being positive or negative is to compare it to zero. Makes sense. So the steps are really very straightforward. We want to take whatever inequality we have and set it equal to zero first. That's our very first step, always. The second step is that we need to find linear factors. We're going to mark these zeros on the number line in the appropriate places, and we're going to test intervals to see whether or not those particular values, whether any particular values within each interval satisfy the inequality itself. I'm going to graph that solution on the number line and write the result whether we wanted an interval or set builder notation. And for the purposes of our demonstrations here, I'm going to use both, but read the instructions carefully and use the appropriate set, whichever one you're asked for. Okay, so let's go over it. We're asked, in this particular case, a really straightforward one. We've got the quantity x minus 1 times x plus 1 times x minus 2 less than 0. And it asks you to solve this nonlinear inequality. Well, we've already met the first two criteria right here. We've got it set equal to 0, and we have all the linear factors, x minus 1, x plus 1, x minus 2. Now we know that x minus 1 is equal to 0 at x equals 1. So I'm going to mark off my number line here very carefully, number my quantities so I know what to test, what not to test. And in this case, I'm actually going to go every other line here and mark 0, 1, 2, 3, and so on. And to the left, negative 1, negative 2, negative 3. And you'll see why I'm doing that in just a moment. But okay, on the number line, I'll mark where I actually have my 0. So I know that x equals 1 is one of my zeros. From the second quantity, I know that x plus 1 equals 0 at x equals negative 1. And from the third quantity, I know that x minus 2 is equal to 0 at x equals 2. In other words, what we're trying to do right here, we find these zeros we're going to find the zeros by solving the equation. In this case, x minus 1 times x plus 1 times x minus 2 equals 0. And so we get x equals 1, we get x equals negative 1, and we get x equals 2 as our three solutions here. Okay, so what are we going to do? Well, what we need to do is we actually need to go in and test. We need to test points. And the way we choose test points is to choose test points, right, where we are picking numbers from in between each of these intervals. So let's say that we pick a test point over here to the left of negative 1. We might choose x equals negative 2. Does x equals negative 2 make this inequality true or false? Well, we're looking for where it's less than 0, so what we want are any inequalities, any values that make this inequality negative. So x equals negative 2, would that work? Well, we can try it. At x equals negative 2, we test. If we take negative 2 minus 1, we multiply it by negative 2 plus 1, and multiply that by negative 2 minus 2, do we get a quantity that's less than 0? Well, the answer, of course, is yes, because we're going to get a negative here. We're going to get another negative here, right, negative 1. right? And we're going to get another negative right here in the third quantity. And a negative times a negative, that's a negative 4 actually, right, is less than 0, right? We do end up with a negative number, and so that's true. If the inequality is true for any number within that interval, it's true for all the numbers within that interval. So our interval right here from negative infinity to negative 1 is part of our solution. All right, so we put our parenthesis right here, and we can color that all in and see whether or not that makes it true. Our next interval goes from negative 1 up to positive 1, and we ask, do any values there make it true? Well, nice easy number to test is x equals 0. Let's see what happens if we let x equals 0 in our original inequality. Well, we substitute it in. We're going to have 0 minus 1. We're going to have 0 plus 1. We're going to have 0 minus 2. Does that make it true? Well, does that make it less than 0? In this case, we see that negative 1 times positive 1 times negative 2 is a positive number. And this inequality obviously is not true. Therefore, this is not part of our solution set. Now we go to the next quantity, right? How about somewhere between 1 and 2? Well, we are going to have to test this part of our solution set. So let's try x equals 1.5 or 3/2 and see if that makes it true. Would this make the inequality a true statement? Well, if we take 1.5 and subtract 1, multiply it by 1.5 plus 1, and multiply it by 1.5 minus 2, right? All we're doing is we're taking this original inequality and setting each x less than, do we get a number that's less than 0? Is that true? Well, yeah. We're going to get a positive number here. We're going to get a positive number here, and we're going to be multiplying that by a negative number here. And a positive times a negative is negative. Whatever negative number we come out with, it is less than 0. So that's true. So the interval between 1 and 2 is a true one. So now we need to test one more right here. Let's test one other point, this time in the interval from 2 to infinity. Does that make it true? Well, let's test x equals 3. Test x equals 3. Does that make it true? Well, in this case, no, right? 3 minus 1 times 3 plus 1 times 3 minus 2 does not give us a number that's less than 0, because positive number 2, positive number 4, and positive number 1 is not less than 0. So our solution set includes everything to the left of negative 1 and the set from 1 to 2. And so we would write this in interval notation as our solution set. If we were looking for set builder notation, very similarly, we might write the set of all x such that x is less than negative 1, or x is between 1 and positive 2. And that would be the equivalent set builder notation solution set. Okay, more to come in the next videos.